Today's lesson is on the FOIL method. We use the FOIL method when we are multiplying a binomial by another binomial. The FOIL method gets its name because it is the order in which we're going to multiply the numbers in each binomial times each other. The f of the binomial is referring to the first number. In other words, it is the first number of each binomial. Here we have a binomial x plus 3, and we have another binomial 2x minus 4. The first numbers in the first binomial is x, and the first number in the second binomial is 2x. So the f of the FOIL method tells us our first step is to multiply those two numbers together. So x times 2x is going to be the same as 2x squared. We get x squared because x times x is x squared. The next step in using the FOIL method is the O. The O is referring to the outside numbers of each of the binomials. Here, our outside number on the first one is x, and the outside number of our second binomial is -4. Don't forget to watch for that negative. So x times -4 is going to be -4x. The I of our binomial is referring to the inside numbers in each of the binomials. So our first inside number is 3, and our other inside number is 2x. So now we're going to multiply both numbers together. 3 times 2x will be 6x. The last step in our multiplying our binomials is to multiply the last numbers together. That's going to be the last numbers of each binomial. In our first binomial, our last number is 3, and in our second binomial, our last number is -4. 3 times -4 is -12. I'm going to complete simplifying this binomial or multiplying these two binomials, and then I'm going to go back and redo this in a neater way so you can see again how we did that. If I have, this should be 2x squared. If I have 2x squared, there's nothing else in this polynomial that I can add to 2x squared because I have no other number with a 2 for an exponent. So when I simplify it, I'm going to be left with 2x squared. When I'm simplifying my next terms, I notice that I have a -4x and a 6x because I have the variables, because they're the same and they have the same exponent. I can add those together. -4x plus 6x is going to be 2x. So that's plus 2x. There is nothing to add to my -12, so I just can add that on the end. And here I have 2x squared plus 6x minus 12. The FOIL method is also called the claw, and it gets its name the claw because when you're actually distributing the numbers, you kind of create a claw. So I'm going to redo this problem very quickly just to show you how you can make a claw out of this. If you think of this as just a distribution, and you're going to take each term of this first binomial and distribute it to the terms of the second binomial. So to start off with, I'm going to take my x, I'm going to multiply it times the 2x. Again, that's your first in your FOIL. And when I do that, I'm going to get 2x squared. I multiply my x then by my -4, and now I have a minus 4x. Then I take my second term, also my inside numbers, and I'm going to distribute it to the next, which is going to be 3 times 2x, which is 6x, and 3 times -4, which is minus 12. I wanted to redo this problem just so you could see it in a neater version and how it kind of creates a claw here for you, and that's how it gets that word, the claw. Then I'm going to just simplify my expression here. Again, there's nothing to add to 2x squared. The -4x and the 6x can be added together, so that will be 2x. and that will be minus 12. So my product of x plus 3 times 2x minus 4 is going to be 2x squared plus 2x minus 12. Here are some problems that we can use to practice. Here we have the binomial 2x minus 5, and we have the binomial x plus 4. We're going to multiply these together, and to do that, I'm going to multiply 2x times x, and again, I'm going to get 2x squared. Then I'm going to multiply my 2x times my 4, and I'm going to get 8x. I then multiply my negative 5 times my x. Watch for that negative, negative 5x. And my negative 5 times my 4, and I will get a negative 20. My problem is not completely done until I have simplified my terms, my expression. So when I'm looking at this problem, I can see the only things I'm going to be able to combine are the middle numbers. So then I'm going to have 2x squared plus 8x plus negative 5x is going to be 3x minus 20. And I've multiplied my two binomials together. The second example is very similar. Again, we're going to use the FOIL method by multiplying the two first numbers. X times 3x will be 3x squared, and x times negative 4 will be negative 4x. Negative 8 times 3x will be negative 24x. And negative 8 times negative 4 is going to be positive 32. A negative and a negative makes a positive number. Oh, I forgot my x right here. Again, my two middle numbers are the numbers that I can combine. So I'm going to have 3x squared. Negative 4x and negative 24x is going to make negative 28x plus 32. All of the problems we did so far are very similar in that the middle numbers the middle terms are the ones that you are going to be combining. In this next example, we are going to use the same method that we had with the other ones, but here we do not have a binomial and a binomial. So we're not really going to use the FOIL method, but we're going to use the same process that we used with the FOIL method. Here I have a binomial 2x squared minus 1, and I'm going to multiply that times the trinomial 4x squared minus 3x plus 2. Again, I'm going to use that same method where I distribute the terms of the first binomial to each of the terms of the trinomial. So I have 2x squared, and I'm going to distribute that or multiply that times 4x squared. 2x squared times 4x squared is going to be 8, because 2 times 4 is 8. And then x squared times x squared is going to be x to the fourth power. As you recall from multiplying exponents, that whenever I multiply two variables with an exponent, I am simply adding those two exponents together, and 2 plus 2 is 4. So 2x squared then times negative 3x. My 2 times my negative 3 is going to give me negative 6. And my x squared times my x is going to give me x cubed. 2 plus 1 is 3, so I have a cubed. My last one I'm going to multiply is 2x squared times 2. 2 times 2 is 4, so I have a positive 4. And then I have x squared, and there's nothing there to multiply it by, so I just carry it over x squared, just like I multiplied it times 1. Then I'm going to repeat the same process with the second number in that binomial. So I have negative 1 times 4x squared, and I'm going to have negative 4x squared. Then I'm going to multiply negative 1 times negative 3x, and that's going to give me a positive 3x. And I'm going to multiply my negative 1 times my 2, and I'm going to have negative 2. I'm done multiplying, but I am not done with the problem because I can't finish until I have combined all my like terms. So when I look at the first term, 8x to the fourth, I do not have anything else that has the exponent of 4, so I'm going to write that just like that is, 8x to the fourth. Then I look at my negative 6x cubed. Again, I don't have anything that I can combine that with, so I'll just rewrite that, negative 6x cubed. When I look at my next term, I have 4x squared, and then over here I have a negative 4x squared. So I can combine those two terms. A positive 4x squared plus a negative 4x squared is just going to cancel out and be 0. So these two numbers are canceling out each other, and so I don't write anything down. I have 0 there. And then I have 3x. Again, there's nothing to add to 3x, so I just put 3x, and then I have the negative 2 left over. When I multiply 2x squared minus 1 times 4x squared minus 3x plus 2, my answer is going to be, the product will be 8x to the fourth minus 6x cubed plus 3x minus 2. Now we're going to use the same concept but with functions. Here I have the statement, if the f of x is equal to 7x minus 3 and g of x is 2x plus 2, find f of x times g of x. Remember that this dot just means multiply them together. So even though there's the letters in there, I'm still going to use the exact same thing as I did before. I'm going to take my f of x, which is 7x minus 3, and I'm going to multiply that times my g of x, which is 2x plus 5. I will use the FOIL method just like I did with the other problems. 7x times 2x is 14x squared, and 7x times 5 is 35x, and negative 3 times 2x is negative 6x, and negative 3 times 5 is negative 15. Again, I multiplied my first numbers, my outside numbers, my inside numbers, and my last numbers. So I use the FOIL method. Before I can finish, I need to simplify what I have here. In the middle, 35x minus 6x, those are the only terms I can combine. So I'm going to rewrite this as 14x squared. 35 minus 6 is 29, so plus 29x minus 15. F of x times g of x is 14x squared plus 29x minus 15. Now we're going to try a problem that is just a little bit more difficult. It's a little more complex, and we're going to use the same ideas that we've used throughout this unit of combining polynomials and multiplying and using the FOIL method, and we're going to simplify this problem. Now, as you recall from using your orders of operation, that in orders of operation, the first thing we do is parentheses. Of course, there's nothing in this problem that we're going to be able to combine because every one of these binomials have different terms in them, so you cannot add anything together. The next step is your exponents, and there are no exponents here. The next step is to multiply or divide, and we do have some multiplication, and the last step is to add or subtract. So we're going to use our PEMDAS to simplify this expression because that's what PEMDAS is for, is to simplify variable expressions or any kind of expression. But we know that we do not need to use the parentheses and we do not need to do the exponents because there's nothing that we can do with those two methods. So we're going to start with multiplying. The most important thing that you need to remember when you're doing problems like this one is that you do your multiplication first. It would be very easy to think that you needed to distribute this negative sign and change the signs in here, but you do not do that because you have to multiply before you can deal with that minus sign. So with that said, we're going to use our FOIL method to do our multiplication, and we're going to first multiply our two first numbers. So we have x times x is x squared. And x times negative 1 is negative x. And negative 2 times x will be negative 2x. And negative 2 times negative 1 is going to be positive 2. Now I'm going to put this problem or this expression in parentheses just so that I can show that it was my problem that was up here, that it was the same thing, and that I don't get it mixed up with this minus sign that I'm going to write in now. Because what I'm going to do is I'm going to carry this minus sign down. So I'm going to subtract, and then I'm going to use the FOIL method again. But again, I'm going to put my product after I multiply these together inside parentheses, just so I keep my problem straight. 2x times 3x is 6x squared. And 2x times negative 3 is negative 6x. Negative 2 times 3x is going to be negative 6x. And negative 2 times negative 3 will be positive 6. Before I deal with that minus sign, I'm going to go in and simplify both of my polynomials, and I'm going to keep them in the parentheses while I do that. So to start off with, I have x squared, and I'm going to combine these two terms here. Negative x minus 2x is going to be negative 3x. And then I have that plus 2. I'll put that back in parentheses so I remember that's my separate polynomial. And then I'm going to combine my terms right here. I have a negative 6x and a negative 6x. So I'm going to have 6x squared minus 12x plus 6. Now I'm ready to move on to my next stage because I've done the multiplication, and I'm ready to go to adding and subtracting. Whenever I have a minus sign, a subtraction sign outside of parentheses, I am going to have to look at this as saying there's a negative 1 out here, and I'm going to need to distribute that negative 1 to everything in the parentheses. I cannot just take off parentheses on my expressions unless there is only a plus sign on the outside. So to start off with, I can take the parentheses off of this first one because there's no symbol here. So I can take this off. So I can say x squared minus 3x plus 2. Now, in order to take the parentheses off the second polynomial, I'm going to distribute this negative 1. So negative 1 times 6x is going to be negative 6x squared. It was a positive 6x squared, but when I distributed the negative 1, it then became negative. Then I'm going to distribute my negative 1, or my negative sign, to my negative 12x. It's a negative 12x times a negative 1 is going to make that a positive 12x. Then when I distribute my negative 1 to my 6, right now my 6 is positive, but when I distribute that negative 1, I'm now going to have a negative 6. So my 6x went negative, my negative 12x is now positive, and my positive 6 is now a negative 6. I often tell my students that whenever you have a negative sign outside the parentheses, basically what you're going to do is you're going to change everything inside the parentheses to the opposite of what it is, because that negative sign is saying it needs to be its opposite. A big mistake that people will make is they will change this negative 6, but they won't change anything else. So you need to be very, very careful that you change everything inside the parentheses to its opposite. Now I can combine my like terms, simplify my problem, and then I will have my answer. So here I have an x squared and I have a negative 6x squared. I'm going to put those together before I add them just so I don't make any mistakes. X squared plus negative 6x squared. Then I have a negative 3x and I have a positive 12x. So I'm going to rewrite that, negative 3x plus positive 12x, and I have a 2 and a negative 6, plus 2 minus 6. I combine my like terms together. Negative x plus, or excuse me, negative x minus 6x will be negative 5x squared. And I said negative x, but it's x squared plus negative 6x squared. And then negative 3x plus 12x is going to be a 9x, positive 9x. And 2 plus negative 6 would be negative 4. So when I have a problem such as this where I need to simplify a polynomial and I have two binomials. If I had x minus 2 times x minus 1, and from that I'm going to subtract 2x minus 2 times 3x minus 3. In that case, I would have the answer, or the product, negative 5x squared plus 9x minus 4. So whenever you are multiplying polynomials or binomials by another binomial, you're simply going to distribute everything in the first binomial to everything in the second one. If it's a trinomial, same thing. You're going to distribute everything in the first binomial to everything in the second one, or the second polynomial, whether it's a binomial or a trinomial.